So this is going to be our midterm review for equations. The test will be Thursday in class on Kidam. It will involve equations and inequalities. So we will review equations today and inequalities tomorrow. The first problem says a car has a 16-gallon fuel tank. When driven on a highway, it has a gas mileage of 30 miles per gallon. The gas mileage, also called fuel efficiency, tells us the number of miles the car can travel for a particular amount of fuel, 1 gallon of gasoline in this case. After filling the gas tank, the driver got on a highway and drove for a while. Number 1, how many miles has the car traveled if it has the following amounts of gas left in the tank? So for number 1, we know that it starts out with 16 gallons. And now there's 15 gallons left. So if we take the original 16 gallons and subtract the 15 gallons that are left, that means the car used 1 gallon of gasoline, and we know that it travels 30 miles per gallon. So 1 times 30 equals 30 miles. B, it says there are 10 gallons left. So we'll use the same method. You start with 16 gallons. You subtract the 10 gallons that are left. This gives you 6 gallons used. And if it travels 30 miles per gallon, then it traveled 180 miles. And C, if there's 2.5 gallons left, then we started with 16. If we subtract the remaining 2.5 gallons, that means we used 13.5 gallons. And those 13.5 gallons could drive 30 miles each. So now we can multiply 13.5 times 30 equals 405 miles. Number 2, write an equation that represents the relationship between the distance the car has traveled in miles, d, and the amount of gas left in the tank in gallons, x. So, if we want the equation to represent the distance, then we have d equals. If we look back at what we did in number 1, we took the 16 gallons when it was full, and we subtracted the amount of gas that was left in the tank. This time we're going to let that equal x. We found this number, and then we multiplied it by 30. So this equation right here will give us distance if we input the gallons left in the tank, subtract the gallons left from the 16 we started with, and then multiply what was used by 30 miles per gallon. 3. How many gallons are left in the tank when the car has traveled the following distance on the highway? And A is 90 miles. So, if we had a full tank of gas, that would be 16 gallons. And we know that it can drive 30 miles per gallon. So 16 times 30 equals 480. So we know that we start with the ability to drive 480 miles. We can take the 480, subtract the 90, and we get 390. Then we can take that 390, divide it by the 30 miles per gallon, and we would find that there are still 13 gallons left. A different way could be take the miles that are driven, so 246, divide that by the 30 miles per gallon, and we find out that we have used 8.2 gallons. Now we can take the 16 we started with, subtract the 8.2, and find out that we still have 7.8 gallons left. Both methods work. Whichever one makes more sense to you, you can use. Number 4, write an equation that makes it easier to find the amount of gas left in the tank, X. So we're going to want X equals, if we know the car has traveled D miles. So the second method we used here would probably be the easier one to write an equation for. We can say that X, the amount of gallons left in the tank, is going to be the 16 that we started with minus the number of miles traveled divided by 30 miles per gallon. This D divided by 30 would represent this part at the beginning in blue, 246 divided by 30, gave us 8.2, and then you can see that we subtracted that from 16. So this equation, X equals 16 minus the number of miles driven divided by the 30 miles per gallon that the car gets, will get you the remaining gallons left in the tank. Noah is helping to collect the entry fees at his school's sports game. Student entries cost $2.75 each, and adult entry costs $5.25 each. At the end of the game, Diego collected $281.25. Select all equations that could represent the relationship between the number of students S, the number of adults A, and the dollar amount received at the game. So if we tried to write an original equation, we know that students are $2.75 each. That would be 2.75 S. And adults are $5.25 each. So that would be 5.25 A. And we know that when you added the money from the students to the money from the adults, it would be a total of $281.25. So now what we're going to do is see if we can create these 5 equations by manipulating the original equation. So in A, we have the 2.75S by itself. To do that, we would subtract the 525A from both sides. So we would end up with 2.75S equals 281.25 minus 5.25A, and that does match choice A, so that would be a correct equivalent expression. Now if we look at B. In B, we want to get A by itself. So if we started with the original equation and we wanted A by itself, the first thing we would do is subtract 2.75S from both sides. And that would give us 5.25A equals 281.25 minus 2.75S. The next thing we would need to do is divide everything by 5.25. This would leave A equals 281.25 divided by 5.25 equals 53.57. Minus 2.75 divided by 5.25 S. This does match choice B, so choice B would also be correct. If we look at choice C attributed the $5.25 to the students, but we can see here that adult entries cost $5.25 each. So C is not a correct choice. If we look at choice D, we can see that they have attributed $2.75 to the adult tickets, but here we can see that student entry costs $2.75. So it can't be choice D. And if we look at choice E, we can again see that they have attributed $5.25 to being the price of student tickets. And we've already said adult tickets were $5.25 and student tickets were $2.75. So it cannot be choice E. So when you're doing problems like this, you need to ensure that you are matching the correct number values with the correct variables when you're writing your equations. Next question. The area A of a rectangle is represented by the formula A equals L times W, where L is the length and W is the width. The length of the rectangle is 5. Write an equation that makes it easy to find the width of the rectangle if we know the area and length. So what you want to pay attention to is that I want an equation to find the width. That means I want W equals. So if my original equation was A equals LW and I want W by itself, I'm going to divide both sides by L. Now I would have an equation that says W equals A divided by L. And if they tell me the length is 5, I could even substitute that in, and I could say the width equals the area divided by 5. Now, if you told me the area, I could divide the area by 5, and my answer would be the width. So make sure that whatever it says you want the equation to find is what you have isolated by itself. Everything else should be on the other side of the equal sign. V equals pi r squared is an equation to calculate the volume of a cylinder V, where r represents the radius of the cylinder and h represents its height. Which equation allows us to easily find the height of the cylinder because it is solved for h? Remember, if I want the equation to easily find the height, then I want an equation that says h equals. So therefore, A cannot be correct and D cannot be correct because I need an equation that says h equals. So I'm going to take my original equation, V equals pi r squared h, and I need to move this pi r squared to the other side of the equation. Pi r squared times height This is all multiplication. So the opposite of multiplication is division. I'm going to divide the right side by pi r squared, and I'm going to divide the left side by pi r squared. So now my equation is v divided by pi r squared equals h. And this is what I wanted. An equation that solves for h, and this matches choice C. So that means B is not correct because we do not subtract pi r squared from both sides. We divide both sides by pi r squared. Andre bought a new bag of cat food. The next day he opened it to feed his cats. The graph shows how many ounces were left in the bag on the days after it was bought. Number 1. How many ounces of food were in the bag 12 days after Andre bought it? So we can see that days is our x-axis down here at the bottom. So we're saying 12 days. So I want to come over here to 12. I'm going to go up until I hit the line. And then once I hit the line, I'm going to look left to see what the y value is, which is the ounces. This value is between 32 and 40. So halfway between 32 and 40 would be 36 ounces. Number 2. How many days did it take for the bag to contain 16 ounces of food? So now they're giving us the ounces, which is our y. So we want to go to 16 ounces. We want to look right until we hit the line. And if we go down from there, we can see that we are at 24 days. Number 3. How much did the bag weigh before it was opened? So it was before it was opened would be at 0 days. So we're on the y-axis. If we go up the y-axis, we can find our y-intercept right here at 56 ounces. So this is how we would determine the weight before it was opened. And number 4, about how many days did it take for the bag to be empty? Well, if we have an empty bag, then we would have 0 ounces. So we are looking for the x-intercept. If we come over, we find our x-intercept in between 32 and 36 days. So we could say 34 days for the bag to be emptied. A Little League baseball team is ordering hats. The graph shows the relationship between the total cost in dollars and the number of hats ordered. What does the slope of the graph tell us in this situation? So notice they're asking specifically, what does the slope tell us? Well, a slope is your change in y over your change in x. And our y is total cost, and our x is hats ordered. So the slope tells us the change in cost over the change in hats ordered. So, if we look through these, A, it tells us there is a fixed cost of approximately $35 for ordering hats. That is not the change in cost over change in hats. B, it tells us the amount that the total cost increases for each additional hat. That is the change in cost over the change in hats. So B would be the correct answer. Just remember that your slope always tells you how much your y value changes every time your x value increases by 1. A group of hikers is progressing steadily along an uphill trail. The graph shows their elevation or height above sea level in feet at each distance from the start of the trail in miles. Number 1, what is the slope of the graph? Show your reasoning. So remember, a slope is how much we change in the y direction. So we can see that we start at 500 feet and we can get to this point right here at 1,000 feet. That is an increase of 500 feet. And we're starting at the beginning of the trail, and our second point is 2 miles along the trail. So that's a change of 2 miles. So 500 divided by 2 equals 250 feet per mile. What does the slope tell us about the situation? Again, a slope is how much your y value changes every time you change your x value by 1. So this is telling us how much elevation changes per mile. Three, write an equation that represents the relationship between the hiker's distance from the start of the trail, x, and their elevation, y. So we now know the slope, and we can see what the y-intercept is. So we can write slope-intercept form equation. If you remember, that's y equals the slope, which we just said was 250, and the slope is always with x, and then we add the y-intercept. And we can see that the y-intercept is at 500 feet. So this would be the equation that represents this graph. Number 4. Does the equation y minus 250x equals 500 represent the same relationship between the distance from the start of trail and the elevation? So they're wanting to know, could we go from our equation to the equation they just gave? Well, if you started with our original equation, you could subtract 250x from both sides, and that would give you y minus 250x equals 500, which matches the equation they're asking about. So the answer is yes. They're equivalent. Kindergarten teacher bought $21 worth of stickers and cardstock for his class. The stickers cost $1.50 a sheet, and the cardstock cost $3.50 per pack. The equation 1.5s plus 3.5c equals 21 represents the relationship between sheets of stickers, S, packs of cardstock, C, and the dollar amount a kindergarten teacher spent on these supplies. Number 1. Explain how we can tell that this graph represents the given equation. We can take the point pairs and substitute them into the original equation, and if it is true, then this does represent the function. So we could take 1.5. We can use the first number here, 0.6. That would be 0 for S, plus 3.5 times 6 equals 21. 1.5 times 0 is 0. 3.5 times 6 is 21. And 21 does equal 21, so that's true. Then we could take this end point and try it again. 1.5 times 14 plus 3.5 times 0 should equal 21. 1.5 times 14 is 21. 3.5 times 0 is 0. And again, 21 does equal 21. So this proves this line is the line that represents this equation. Number 2, what do the vertical and horizontal intercepts 0.6 and 14.0 mean in this situation? Well, X is our sheets of stickers, and Y is our packs of cardstock. So 06 represents 0 stickers and 6 cardstock equal $21. The x-intercept 14 says 14 stickers and 0 cardstock also equal $21. So this is how we would interpret the x and y intercepts in the context of this specific situation. Select all the points that are on the graph of the equation 4y minus 6 equals 12. To know if they're on the graph, you can simply substitute in the points for x and y and see if it makes the statement true. So for A, you would have 4 times negative 3 minus 6 times negative 4, and that would need to equal 12. 4 times negative 3 is negative 12, and negative 6 times negative 4 is 24. Negative 12 plus 24 is 12. That's what we wanted. So A is a correct point. B, you would have 4 times 1.5 minus 6 times negative 1. 4 times 1.5 would be 6. Negative 6 times negative 1 would be 6. And 6 plus 6 is 12, which is what we wanted. So B would also be correct. C, 4 times negative 2 minus 6 times 0. 4 times negative 2 is negative 8. Negative 6 times 0 is 0. And negative 8 does not equal 12. So C cannot be a correct answer. D would be 4 times 3 minus 6 times 0. 4 times 3 is 12. Negative 6 times 0 is 0. 12 does equal 12. So D would be a correct answer. E would be 4 times negative 4 minus 6 times 3. 4 times negative 4 would be negative 16. Negative 6 times 3 would be negative 18. And negative 16 minus negative 18 would be negative 34, which is not 12. So E could not be a correct answer. And F would be 4 times 4 minus 6 times 6. 4 times 4 would be 16. Negative 6 times 6 would be negative 36. And 16 minus 36 would be negative 20, which is not 12. So F could not be a correct answer. So to know if a point is on the graph of an equation, you can simply substitute the values in for x and y, and if it makes the statement true, then it is a point on the graph. A theater is selling tickets to a play. Adult tickets cost $8 each, and children's tickets cost $5 each. They collect $275 after selling X adult tickets and Y children's tickets. What does the point 37 mean in this situation? Remember that the first number in a point pair is always your X. And the second number in a point pair is always your Y. And a X is my adult tickets sold, and Y is my children's tickets sold. And a point on the line is a point that makes it equal. So this means 30 adult tickets plus 7 children's tickets equals $275. Remember, if the point is on the line, it makes it equal. If it's below the line, it would be less than. And if it was above the line, it would be more than. These are the review problems for the equations part of the midterm. Make sure you understand all of this. If you have any questions, please use class time to ask for clarification before the test on Thursday. Tomorrow we will work on the review problems for inequalities.